Hey everybody, how's it going? In this video, we'll be learning about Python class inheritance. Now, just like it sounds, inheritance allows us to inherit attributes and methods from a parent class. Now, this is useful because we can create subclasses and get all of the functionality of our parent class, and then we can overwrite or add completely new functionality without affecting the parent class in any way. So let's go ahead and look at an example of this, and we'll see why this is useful. So for our object-oriented video so far, we've been working with this employee class. Now let's say that we wanted to get a little more specific here and create different types of employees. So for example, let's say that we wanted to create developers and managers. Now these would be good candidates for subclasses because both developers and managers are going to have names, email addresses, and a salary. And those are all things that our employee class already has. So instead of copying all this code into our developer and manager subclasses, we can just reuse that code by inheriting from employee. So let's go ahead and create these developer and manager subclasses. And it's just as easy as creating a new class, just like we did up here with employee, but we're going to call this new class developer. And after the name of the class, we can put these parentheses here and specify what classes that we want to inherit from. So in this case, we want to inherit from the employee class. Now I'm just going to put in this pass statement here for now because I want to show you that by simply inheriting from that employee class that we inherited all of its functionality. So right now, even without any code of its own, the developer class will have all of the attributes and methods of our employee class. So right now, down here I have two instances of our employee class, and then I'm printing out both of their emails. So if I save this and run it, you can see that when we create two new employees and print out their emails, that we get this result. So now, instead of creating two new employees, I'm now going to create two new developers and pass in all of the same information. So now, if I rerun this and print out those emails, you can see that those two developers were created successfully and that we can access the attributes that were actually set in our parent employee class. So what happened here is that when we instantiated our developers, it first looked in our developer class for our init method, and it's not going to find it within our developer class because it's currently empty. So what Python is going to do then is walk up this chain of inheritance until it finds what it's looking for. Now this chain is called the method resolution order. Now I want to show you this really useful function here that makes these things a lot easier to visualize, and that is the help function. So first I'm going to copy out these two lines here, and then I'm just going to print out this help function, and I'm going to pass in the developer class. So if I go ahead and run that, and I'm going to make this a little bit bigger here. Now you can see that when we run help on that developer class, that we get all kinds of good information here. So that method resolution order that I mentioned is one of the first things that gets printed out. And basically, these are the places that Python searches for attributes and methods. So when we created our two new developers here, it first looked in our developer class for the init method, and when it didn't find it there, then it went up to the employee class and it found it there. So that's where it was executed. Now, if it hadn't found it in our employee class, then the last place that it would have looked is this object class. And every class in Python inherits from this base object. Now, if we look at this output further, then it actually shows the methods that were inherited from employee. So you can see here that we have the init method, and we also have our apply raise method and our full name method. And if I keep scrolling down here, then you can also see that we have our data and other attributes, and you can see that the class attribute raise amount was also inherited from the employee class. So we got all of this code for free just by inheriting from that employee class. Okay, so now I'm going to go ahead and make this smaller again, and I'm going to take out that printed help statement. Okay, so now let's say that we wanted to customize our subclass a little bit. Now I'm going to make a very simple one-line change in here, and I'm just going to change the raise amount. But first, let's go ahead and see what happens when we apply a raise on our current developer. So I'm going to print out, this should actually be pay, and this should be pay. Now I'm going to print out our current developer's pay here, which should be 50,000. Then I'm going to apply a raise, and it should find our employee's raise amount of 4%, and then I'm going to reprint out that developer's pay again. So if I save that and run it, you can see that it printed out 50,000, applied the raise, and then printed out 4% higher. But let's say that we wanted our developers to have a raise amount of 10%. Now to change that, it's just as easy as coming into our developer class here and just changing the raise amount to 10%. So now if I go ahead and rerun this, you can see that it used our developer class's raise amount instead of our employee class's raise amount. Now, if I was to change this instance back to an employee instead of a developer and then reran this, then you can see that now it's back to that employee 4% amount. So the thing to take away here is that by changing the raise amount in our subclass, it didn't have any effect on any of our employee instances. So they still have that raise amount of 4%. So we can make these changes to our subclasses without worrying about breaking anything in the parent class. Okay, so now I'm going to go ahead and change this back to a developer, and we'll make a few more complicated changes. So sometimes we want to initiate our subclasses with more information than our parent class can handle. So what do I mean by that? So let's say that when we created our developers here, that we wanted to also pass in their main programming language as an attribute. But currently, our employee class only accepts first name, last name, and pay. So if we also wanted to pass in a programming language there, then to get around this, we're going to have to give the developer class its own init method. So what I'm going to do is I'm just going to go up here to our employee class and grab that init method, and I'm going to paste it here within the developer class. Now, along with the first name, last name, and pay, I'm also going to add in an argument here for the programming language. Now, what you might be tempted to do here is just go up and copy all of this code from our employees class's init method and paste it into our developer class's init method. But we don't want to do that because we want to keep our code dry and not repeat this logic in multiple places because we want it to be as maintainable as possible. So instead of copying and pasting that, what we're instead going to do is just let our employees init method handle the first name, last name, and pay, and then we'll let the developer set the programming language. So in order to let that employee handle the first name, last name, and pay, what we can do here is just do super.init, and then we can pass in the first, last, and pay. So again, super.init is going to pass first, last, and pay to our employees init method and let that class handle those arguments. Now, there's multiple ways of doing this logic here. You may have seen some people do employee.init, and instead of passing in first, last, and pay, they'll type in self and then first, last, and pay. Now, both of these ways of calling the parent's init method will work, but I tend to use super because with single inheritance like we are using here, it's a little bit more maintainable, but it's really necessary once you start using multiple inheritance, and we're going to go over that in a future video. But to keep things simple, I usually just like to always stick with super. So now that we're letting our employee class's init method handle the first, last, and pay, now we can handle the programming language argument just like we would in any other class. So I can just say self.programmingLanguage equals the programming language that we passed in here. Okay, and that should be all we need for our init method. So now when we instantiate our developers down here, it's also going to be expecting a programming language to be passed in. So I'm just going to go ahead and pass in Python for our first developer, and I'll pass in Java for our second developer. So now to make sure that this worked, I'm going to comment out those lines there, and I'm going to print out the first developer's email, and I'm also going to print out the first developer's programming language. Okay, so if I run that, then you can see that both of those were set correctly. So we got the email set by it when we passed in all of our arguments here. It came up here and it ran our employees init method and set all of those within there. And then it also set our programming language within our developers init method there. So you can see why this subclassing is useful, because we were able to customize just a little bit of code, and we got all of this code from our employee class for free just by adding in that one little line there. Okay, so just so we can get a really good understanding of this, let's go through the process of creating another subclass called Manager, and I'll go through all these steps again, but I'll go a little bit faster this time. Okay, so right here below our developer, I'm going to create another class, and I'm going to call this class Manager, and this is also going to inherit from Employee. Now, when I create a new manager, I'm going to give the option of passing in a list of employees that this manager supervises. So we're going to need to add an init method for our manager. And instead of typing all this in, I'm just going to grab this init method here from our developer and paste this in here. Okay, but this is going to be a little bit different. Instead of a programming language, for our manager, I'm going to let them pass in a list of employees, and I'm going to set the default to none. And then instead of setting this programming language here, I'm going to say if employees is none, self.employees is equal to an empty list, and then else self.employees equals employees. Now you might be wondering why I didn't just pass in an empty list as the default argument here instead of none, but you never want to pass mutable data types like a list or a dictionary as default arguments. And that's a topic for another video, and I plan on doing one on that soon. But for now, we'll just go ahead and set our employees to an empty list if the argument is not provided, and set them equal to that employees list if it is. Okay, so now let's add in a few methods here. So I'm going to give the option to add and remove from our list of employees that our manager supervises. And to do this, I'll add in a method called addEmployee. And addEmployee will take self, just like all of our instance methods do, and employee. And then I'll just say if the employee is not in self.employees, then I will just append that employee to our list. So self.employees.append that employee. And now I'm also going to create another method here to remove employees from this list, and it's going to be similar. So I'm just going to go ahead and copy that, but this is going to be remove, and we'll say if the employee is in our list of employees, then remove that employee. Okay, and lastly, I'm going to add a method that will print out all of the employees that this manager supervises. So I'm going to call this method print employees, and this isn't going to take any more arguments than just self. And I'll say for employee in self.employees, and then I will just print out that employee. And before the employee, I'll go ahead and put an arrow here just so it sticks out a little bit further. And instead of just printing the employee, I'll actually print out the employee full name. Okay, so I think that we are finished with our manager class. So we have our own init method here, which it'll accept a first name, last name, pay, and also a list of employees that this manager supervises. And then we have the ability to add employees to that list, remove employees from that list, and to print out all the employees from that list. So now let's see if this works. So I'm just going to comment out these lines here. And now I'm going to create a new manager, and I'll call this manager 1. So now I want this to be a manager, and for the first name I'll do Sue. For the last name I'll do Smith. We'll say that the pay is $90,000. And let's say that she supervises this first developer here. So now let's make sure that this manager was successfully created and that we have all of the attributes and methods available that it would have inherited from that employee class. So let's go ahead and print out this manager's email address. So now if I go ahead and print this out, you can see that the email address was set correctly. But now we also added in all of this extra functionality. So let's see if we can print out all the employees that this manager supervises. So I'll do manager.print employees, and if I go ahead and run that, then you can see that it prints out the full name of the one employee that they currently supervise, and I can add to that list of employees. So here I'll just say manager1.addEmployee, and I'll pass in this second developer here before we print out that list of employees. Now if I print that out, you can see that now they are supervising 2 employees, and we also have the ability to remove employees. So I will remove our first employee here from their list of people who they supervise. So now if I save that and run it, you can see that that first developer was removed from that list, and they only have the second developer in that list. So just like with our developer class, you can see how useful this actually is, because all of the code in here is specific to what we want for a manager. And in our developer class, it's specific to what we want for a developer. And we're inheriting all of this common code from employee. So we really get to reuse our code nicely here if we use subclassing correctly. Okay, so now I'm just going to go ahead and remove all of this code here. Now, I know that this video is getting a little long, but I want to show you a couple more quick things here. So Python has these two built-in functions called isInstance and isSubclass. So isInstance will tell us if an object is an instance of a class. So for example, if I need to print this out, I can print out whether manager1 is an instance of manager. And if I print that out, you can see that it prints true. Now, if I was to check whether the manager is an instance of an employee, then you can see that that is also true. But if I check if manager1 is an instance of a developer, then that returns false. Because even though developer and manager both inherit from employee, they aren't part of each other's inheritance. So along those same lines, we have this isSubclass function. And isSubclass will tell us if a class is a subclass of another. So for example, I could do isDeveloper a subclass of employee. And if I run that, you can see that it returns true. And if I do isManager a subclass of employee, if I run that, you can see that that returns true also. But if I say isManager a subclass of developer, then that will return false. So those built-in isInstance and isSubclass functions may come in use when you're experimenting with inheritance on your own. Okay, so very last thing. I always like to show you all practical real-world examples of this stuff whenever I can. And one of the easier examples I found of subclassing was within the exceptions module of this Python WSGI library. So this is a really popular library and used in a lot of different projects. So if we look here, we can see that this HTTP exception class inherits from this base exception. And they say here that this HTTP exception is the base class for all HTTP exceptions. Now, if we scroll down here, you can see that this has a lot of code in this class. But once we get far enough along, we can see that we have some other classes here that inherit from that base HTTP exception class. So here we have this bad request that inherits from HTTP exception. And since it inherits from that base class, it gets all of that code that we just saw for free. And now it can just simply modify this return code and the description without needing to rewrite all of that code from the parent class. So you can see how using inheritance like this would be extremely useful as your projects grow in size and makes everything much easier to maintain. Okay, so I think that is going to do it for this video. In the next video, we will go over special and magic methods and how to use those within classes. But if you do have any questions about what we covered in this video, then feel free to ask in the comment section below and I'll do my best to answer those. Now, if you enjoy these tutorials and would like to support them, then there are several ways you can do that. The easiest way is to simply like the video and give it a thumbs up. And also it's a huge help to share these videos with anyone who you think would find them useful. And if you have the means, you can contribute through Patreon, and there's a link to that page in the description section below. Be sure to subscribe for future videos, and thank you all for watching.